I know, can you imagine? So my sweet students just informed me that I have not been recording, but up until now we've just been kind of going back and discussing how just because the numbers are bigger does not automatically mean that they'll be greater than, unless, like we see in this example, that they are in the same place value for the decimals, okay? Check the whole numbers, and then if you're in the hundredths place for both, the bigger number does win. But as we can see down here with 5/10 and 15/100, that does not always work. So our first way that we have looked at comparing those fractions or decimals rather to decide which is bigger is definitely we can draw a visual. I would encourage you again, if they're in the hundredths or even thousandths, well, hopefully by the thousandths you won't need a visual, but I would just draw them in tens so that you don't have to draw all the tiny little lines. Another way that you can look at fractions, I'm sorry, I keep saying that, decimals, is you can compare them on a number line. So for example, let's look at 8.3 and 8.7. Y'all good? I hear some whispering. Is everybody okay?
Yeah.
All right. All right, let me see if this one draws. So go ahead and write those down. Now I'm just going to draw myself a little number line down here. Okay. For some decimals, you can think of them on a number line or even kind of round them a little bit to decide which one is bigger. So here, let's say I have 8. I start with 8, and I'm going to close out with 9 down here on my number line. Everybody good? So let's see. I've got 1, so that'll be 1, 2, 3. So this is 8.3. 4, 5, 6, 7. 8.7. All right, so we're looking right here and right here. Now this is all about placement, okay? Y'all finish writing that and hear what I'm saying. When I look at 8 3/10, I have to decide, like if I'm looking at whole numbers, what is it closer to? 8 or 9? Right? It's kind of like when we're rounding. Either it's going to stay the same or it's going to go up. So if I look at 8.3 here on my number line, is 8.3 closer to 8 or is it closer to 9? ODG? It's closer to 8. Yeah, go ahead and go. All right. And then I have to compare that with 8.7. Is 8.7 closer to 8 or closer to 9? Jackson?
Closer to 9.
Closer to 9. So which one's bigger?
8.7.
8 and 7/10. Yeah, this one is bigger. Just looking at these, even without that number line, if I was like, okay, you know what? Let's just round 8.3. I'm rounding to 8. I would look at the 3. Either I'm staying in 8 or becoming a 9. What would happen, Nehemiah?
Well, you would tell me the, I just had this in my head. You would tell me,
Staying in 8 or becoming a 9?
staying in 8.
Staying in 8 because 3 is less than 5. Same thing over here with 8.7. I look at that 7. I'm rounding the 8. It's either staying in 8 or becoming a 9. 7 is bigger than 5. 5 or more, let it soar. So 8 would become 9. And does that make sense? Give me a thumbs up if you're with me. Now, obviously, this is only working if the place value in your decimals is the same. Also, you'll notice that the whole numbers are the same. Okay, but you can get an idea. If this was 9.3 and 8.7, which one would be bigger?
9.3.
9. You're going to look at the whole numbers first and foremost, right? That one is a given also. Okay, are we good so far?
Yeah.
I need to flip my page. If you still have room, you can leave yours. Let me do a bumpy bump. I'll do the bumpy bump. All right, so let me flip the page over here. I gotta plan this stuff. It is not just coming to me. All right, now let me give you another example. So now we've talked about two ways to compare fractions, right? We can draw a visual. We can imagine them on a number line. Actually, we talked about three ways. We can round them if they have the same whole number and place value. Okay, so now I want to talk about something else we can do. So I've got 14 and 3/10. And I'm going to compare that to 14 and 13 hundredths. Now, for this, the first thing you might notice is that the whole numbers are the same. So, again, if the whole numbers were different, this would be over because the biggest whole number wins. Agreed? Y'all with me? The biggest whole number wins. But if they are the same, now I'm going to take the decimals and I want to look at them as fractions. So I've got 3/10 and 13 hundredths. Okay, so now I'm going to compare these two things. Okay, so I'm going to bring them down here and I'm just going to put them side by side. Oh. All that one more time. Now this has to be done exactly right or it will be wrong. Anybody need a second to finish writing? Okay. Take a second to get it all written down. Don't make us wait for you. All right, let's keep going. Now, I want you can start from either bottom number, but you're going to go from that number and draw an arrow to the opposite side. Right? We're opposite. 10 to the 13. What is 10 times 13?
It is 130.
Jolie? That's correct. Raise your hands next time, though. Remember, guys, if you have a 0 at the end, and we'll actually have a quick lesson over this, either tomorrow or Monday when we get back, we can drop zeros, okay? Same thing here with 100, and I want you to just from that bottom, go ahead and take the line from 100 to 3, okay? And now we're going to multiply. What is 100 times 3?
300.
It's 300. Which number is bigger?
300.
Victoria?
300.
300 is correct. So, there's your answer. 14 and 3/10 is greater than 14 and 13 hundredths. Y'all good?
All good.
All good. So you can cross and multiply your decimals as fractions to find the larger or smaller fraction. And that translates directly back up here. Any questions about that?
No.
Are we good? Give me a thumbs up, in the middle, thumbs down. Let me know where you are. Okay. Well, that's your problem for going TT potty. All right. Now, here's another one. So we can cross multiply. That's like a fourth way. Look at this example again. So this is another one where if you are looking at decimals and you're reminding yourself, I can't just pick the bigger one, right? I can't just pick the bigger one. Another thing that you can do is you can compare your decimals to what their halves would look like. So go ahead, and I want to write these decimals as fractions. So I'm going to write this as 7/10 and 55 over 100. Now we've been going over that and everybody's good, right? We can make a fraction from our decimals, yes?
Mm-hmm.
Say it.
Yes.
Yes. You're scaring me. Don't make me go to Walmart and be a door greeter.
Are you seriously?
Absolutely. And I'll just ask people as they walk in, what's 9 times 8? Oh, wait, sorry, I forgot I'm not a math teacher anymore. I'm a Walmart greeter. Blame it on the 4th graders at Fellowship Academy. I'm just kidding. Okay.
But it's going to be different for 4th graders.
We'll always blame you.
4th graders.
We'll always blame you. Okay. Too much drama. Now, if I look at 7.5, let's look at that fraction. What would the fraction of half of this be? Think about that for 1 second. I've got a fraction that's 7/10. What would a fraction that represents half equal? The top of my fraction represents the part or the pieces. The bottom number tells me how many pieces make a whole. So if 10 pieces make the whole cake, what's a fraction for half the cake? 5/10. So 1/2 would equal 5 over 10. Oops, let me do this. So what? What do we do with this? Is 7/10 more than a half? It's more than half, right? Okay, so let's hold on to that. What about 1/2 of what 55 hundredths represents? What would the fraction be for half of this cake? 50, right? Half of 100 would be 50 over 100. Now, is this one bigger than 1/2? Which one's bigger, though? So this one is like 5 little pieces over 100.
5 over 10.
But this one is like 2 big slices bigger than half. Are you with me?
Yeah.
So we're comparing our fraction to what half would be. So it just gives you like this picture even in your head that's so much simpler than drawing it out. You're like, well, I mean, is it even half? Okay, it's a lot more than half, right? This one is just a little more than half. So 7/10 wins. There will be times when one of these decimals isn't even half. Boom, done. But finding a fraction of half is as simple as splitting that bottom number. So that is also a really quick way to just look at them. It won't always work, right? Nothing ever does. But it's a quick way to check and say, hey, which one is closer? Okay. Any questions about that?
No, ma'am.
Let me give you one to do yourself. I hate making these up. Let me see. I need the Lord to help me. So, what about... Okay, using that technique I just told you, comparing these to halves. Oh, my goodness.
Oh.
I need the Lord to help me again. Let's look at that. Now compare those two, and I want you need to be able to talk me through which one's bigger or smaller than half and what that means. How did you use that information? I'm just gonna pretend that this didn't happen. Look how tidy Miss Span is. Never makes a mistake. All right. She's a crafty genius. All right, work on that for a second. Okay, raise your hand if you think the answer is greater than. Raise your hand. Anybody? Oh. Raise your hand if you think the answer is less than. Some of y'all ain't answering. Victoria, what do you think? Now, how do you say it? Which one do you think is bigger? The 3/10? Okay. Why? Because what? Okay, well, let's go the other way. Seemed like most of you thought the 4700ths was bigger. Who is brave enough to tell me why? Jackson Edwards raises his hand boldly. Tell me how you worked that out. And remember, we're thinking of it in halves, right? That's what I want to hear. Okay, so talk us through it. Okay.
Split the 100 into a 50 and compare the two in half. And it was closer to its half than this 3/10. Also didn't.
Okay, so he put the 47 over 100, and then he said half would be 50 over 100. And 47 is pretty close to 50. Okay, it's off by like 3 little bitty pieces of cake. Then he said he took 3/10 as a fraction. And he said this, half of this, a fraction would be 5. So this one, and so, and look here, this one is off by 2 pieces. This one is off by 3 pieces. Right? So 3/10 is 2 pieces from being half. 4700ths is 3 pieces from being half. Why isn't 3/10 bigger then, Jacob?
Why is it 3/10 bigger than?
Mm-hmm. Yeah, well 3/10, if it's 2 away.
Pieces?
Huh?
Isn't it like 3 big whole pieces?
Yeah, so
7 small pieces?
yeah, he's saying that the tenths are way bigger pieces, number one, right? The 40 in the hundreds, those are teeny tiny pieces. So these are smaller. So even if you're farther away from half, 47 is still going to round to 50, right? 3 would not make it because it's less than 5. All right, are y'all good there? So yes, that would be correct. 3/10 is less than 4700ths. Okay, does that make sense? Okay. Now, if we are comfortable with you have all of these ways, right? There's about 4 or 5 different ways that we've talked about, Nehemiah, for comparing 2 fractions. I would suggest kind of remembering all of them because I think that you could use something different depending on what your decimals look like. Right, Jacob? Okay. So the next thing that you would have to do with this information, if we can compare the decimals, then we need to be able to order them in order from, least to greatest, greatest to least, whatever it might be. So let's go ahead and let's talk about ordering the decimals, and I'm going to make mine girlified. I did. I'm out of space. Now remember that my notes might be different than your notes. But yes, go ahead and put yourself a little heart there. Maybe a little heart over there. No, it's in there already. It's comparing and ordering. So it's just, we're continuing. Alrighty.
Maybe some stars.
Sure. You want some stars? You do you, boo.
Maybe some squares.
And art class is over. So, go ahead and put that word in. Now, let's look at an example for this. So, let's say we're looking at 3 decimals. And I'm just going to put G to L here, right? So this, number one, let me tell you this. Read the directions. This is why I try to go through all the worksheets with you and make you underline the instructions, because someone will get to this section of the workbook and they will put the numbers in the wrong order. They'll go least to greatest because they will not read the directions. Excuse me. So you have to be aware if they're asking you least to greatest, greatest to least. All right, so the first thing that we want to look at when we are checking these numbers out is what? What am I gonna look for first? I have to decide which of these goes first, which is the greatest decimal of all. Dang it. Always out of time. What do you think? Look at the decimals that we have. Nehemiah?
1.6.
Yeah. We're going to look for whole numbers, right? Let's just write that one whole. This is the only decimal with a whole number. So it goes first. Okay, so I'm going to write it first. I'm going to write 1.6. We're going to go through the whole numbers, and we're going to organize the greatest to the least by the size of the whole numbers. What else would I do next? And I'm left here with 7/10 and 1300s. Nehemiah?
I'm going to go for 7/10.
Why?
Because 7/10 is bigger pieces than the rest. This is 13 small pieces.
Oh. I mean, there's a couple of things that pops in my mind. I'm looking at 7/10 versus 1300s. Immediately, I think half of this is 5. Half of this is 50. Which one's closer to half? The 7, right? Are y'all with me?
Yeah.
Because it's bigger than half. So which is bigger then? 7/10 or 1300s? 7/10. So, guess what? It was already in order, least to greatest. Okay? Of course, then if they ask for least to greatest, we could just flip them around and go that same way. Okay? But you see kind of what you're going to have to do. You're going to have to compare these two. And you can just come down and write them as fractions. You can draw them out if you want to. But when I tell you, like, compare them to half, that's a very quick way in your own, just in your mind, for you to look at those two decimals and just quickly know that 7/10 is bigger. Okay? Are y'all with me? I think that's all the notes I had planned on. Yeah, you know what I want to do though? Go ahead and let's do one you do. And I want to just give you some numbers and let you work them through yourself before we go and see how we do. All right, let's do these least to greatest. Okay, I'm just going to put that up here, least to greatest. You'll take a second, look at those, see what makes sense, and go from there.